Good morning, everyone. It's very nice to be here today, this morning. In today's presentation, I'm speaking about how we can enable privacy-preserving edge computing using TrustZone. So I have structured my talk into two parts. In first part, I'm giving an overview of what is edge computing and a data box platform which we have been working since last 1 year. The second part, I will be focusing on what is TrustZone and how we can make use of TrustZone in Databox. So let's start with what is edge computing. Edge computing is processing of data or information at the edge of a network. Apart from many advantages edge computing gives, the one which is very important to us is that it enables processing of personal data locally, which we acquired from smart environments around us. Instead of sending data to IoT cloud, whatever the data we have, like IoT data to cloud, a user downloads apps on their local data processing hub, which we call Databox. This setup gives user more control over their personal data. What that means? It means they can decide with what kind of information, when, how, and with whom they would like to share their information. This configuration requires mutual trust between the data processor and application provider. So let's have a look by considering an example. I'm here giving an example of a girl called Elsie. She would like to buy a health insurance policy for herself. What she does is she downloads an health insurance comparison app on her local data box and feeds her all personal information into this application. For example, her medical records or her lifestyle information, like what she eats in a week by putting her grocery list, or her Fitbit data, something like that. And this app gives her a best suited insurance policy to her and tell, okay, this is the best insurance policy for you, depending on the information which you have provided. What we are gaining in this is that Elsie doesn't need to send her all personal information to a cloud or to outside world. Her all data is staying in her local data box platform. So this is the scenario which we are exploring in Databox project. So let's have a look at what is inside Databox. So Databox is composed of a number of components. All components are running as an individual component inside as a Docker containers inside a Docker environment. We divide the components into two categories. One we call core components and other are user components. The core components contains container manager, arbiter, data stores, and export service. Whereas user components are drivers and apps. The user components are provided by the users to use the information from the IoT devices or from other social media, and apps process those data which is captured from the smart environment by drivers stored in data stores. If we look at the core components, the one is we call manager, as its name suggests. This is a core component of the data box which manages all other components in the platform, which means it is responsible for installation and deployment of all components in the start. The other component is arbiter. This component is responsible for maintaining the authentication between different components in the network, in the platform. For example, when a new application is installed in the platform, container manager and arbiter are responsible for giving validation to this app that, okay, this is an authorized app which can run into the platform. If we look at the down, there's only one component which we call export service. This is the only component in the platform which exports data outside of the box. So that gives us a good accountability in the platform. It means we have it control and check what data. If we have, for example, 10 of the applications running in my system, only export service provide me the API to give my data outside of the box. So we can check what data is going out of the box. So that's the kind of a bit of overview of the data box. So next part of my presentation, I would like to focus how we can use TrustZone in data box. So before I start, I would like to give a bit of what are my questions when we thought about this. So here we start with the following questions. What is TrustZone? How can we use trusted execution environment from a container running in an untrusted user space? And third is, how can we run a container inside a trusted execution environment? So let's start with what is TrustZone. How many of you have heard about TrustZone here before? Good. So I will just quickly give a quick overview of this slide. So ARM chip enables hardware-based isolation. It's not just a processor, but it goes to other peripherals and other components in the whole system. For example, we can see there are a couple of components which are blue are only enabled in a secure mode, whereas green components are normal mode, and some of the resources are shared when my system switch between a secure to non-secure mode. So we looked at the TrustZone, which is provided by at a hardware level, but what is trusted execution environment? Trusted execution environment includes hardware-based trusted isolation, which is provided by ARM chips. Then it requires a trusted boot plus trusted OS. So in current setup, ARM provide both hardware-based isolation and trusted boot, but trusted OS is third-party applications, which is given by a number of vendors. Some are open source and some are proprietary. So I'm coming back to my second question here. How can we use TE from a container running in a trusted user space? Yes, there is a solution of this. In recent year, a number of research communities have explored this question and designed few solutions. For example, first is SCON, which was published in OSTI 2016. This system built securing Linux container using Intel XGX, and the second one is Samsung Knox, which uses ARM-based devices. Even though like TrustZone and technology is here since more than a decade, but we were not hearing about it, and since we started hearing about it in the last few years only. The reason is because most of the trusted execution environment was proprietary to the vendors. It was locked in. So right now, OPTT is like Open Portable Trusted Execution Environment by Linaro, opens up a new opportunity for open source community and third-party developers to give it a try how we can use and explore more trusted applications in this domain. So now my question, I'm coming back to my data box, how we can use TrustZone in data box. We are exploring our possible solution based on ARM v8 A architecture 64-bit, ARM-trusted firmware, which is recent firmware 1.4 version, Linaro OPTT version 2.5, and Linux kernel. There are a couple of challenges we have when we are building our solution. One is because TrustZone provide only one TTA, only one trusted execution environment, which means there's only one active session. What that means is that when an application is running in my secure zone, there can be only one instance of application active at a time. So my design is get influenced by this consideration. Second is shared memory between secure and non-secure world. So if we say my whole system can switch between secure and non-secure world, but there is a shared memory. So that is my operating system, either is secure, trusted OS, or my application has to take care of how we can use this secure space in a secure manner. Second is context switching overhead. Because there is a monolithic dispatcher in firmware which is provided by ARM, which is called ARM tested firmware, there's a delay, because if there's a new request come for a new interrupt or new request come, only one can be processed at a time, which introduces significant delay in the network, in the whole system. So this is a design consideration, how we can design efficiently our system. And third is small size RAM. Mostly on ARM SOC, there's a very small, on memory is very small, depending on SOC vendors. It is varying from nearly 70 kbits to 500 kbits. For example, right now we are using high-key board, which has only 72 kilobits of secure SRAM on the board. So, which means we need to make use of some page table management and taking a RAM from a TrustZone DRAM. So these are kind of challenges we are addressing right now. So considering all the challenges, we come up with the possible solution which we are exploring in our DataBox platform. If we see these are the black boxes, are the new components we are introducing as our own components. If I see an example here, I take my DataBox I pick two main components of DataBox. One is DataBox Container Manager and Arbiter. Both, we analyzed the code, and we selected the more secure bits of the components which we would like to run in secure user space, which I call TCM and tarbiter. What TCM bit is, it is a bit which provides token to a new app or driver when we register in our DataBox platform. So if we secure this bit, which makes DataBox more secure in the term that no new unauthorized application get registered themselves inside a box. And the arbiter, the trusted arbiter, the code which we are putting in secure user space is, as I said before, the arbiter part of the DataBox is responsible for authenticating the communication between different components within the system. It also controls how much data an app can export outside of the DataBox. So it coordinates with the export service. So when an app gets installed in the DataBox, it requests permission for a data type. Okay, I need to export that set of data outside of the box, and which initially being granted based on a service level agreement between user and the application. But if a malicious app get access to Arbiter and try to change this permission, then they can export the data which was not previously been agreed. So that's why we would like to put that part in Arbiter in a secure mode. So once it's secure, even if there's any malicious component in the DataBox, they cannot change these permissions to export the data outside of the box, which was not agreed previously. So I'm coming back to the black boxes here in the platform. I will go with a bit of architecture. In the bottom, we have a trusted firmware running. Then I'm using OPTT driver, which is running in Linux. Then we are having a container engine. We wrapped all the OPTT client library and T-supplicant inside a container so that it enables reusability of the whole system for different apps within the data box. We are writing our own scheduler, which will provide scheduling of the API call for different components in the data box, like container manager and arbiter. They can schedule themselves when they would like to access what. And then we have data box TT API wrapper. It means right now all the OPTT APIs are written in C and not. We need, if our applications are coming from different other languages like Python, Go, or any other language we require, it would be nice to have a different language library. Plus, it's just not a language library, but it also acts as a filter for us to secure system calls which are being made by different components of container to our kernel and OPTT drivers. So we are try to make use of different Linux security libraries as well. Plus, we are also planning to make try to build our own filters, which is designed based on the policies of the data box. So that's kind of a bit overview of the work which we are doing. This part of the data box project is in work in progress. So there would be some changes in next few months. We are open to suggestions on this part. If someone is working on these bits and pieces and they have their own experience, we are very open to for suggestions and advices on this. So thank you very much for your attention. Any questions?